Comet 3I Atlas is very different from anything we've seen before. Mars is filled with fragments from ancient impacts. ESA loses contact with JUICE right before an important flyby, and the highest resolution image of a solar flare ever seen. And on Space Bites Plus, why asteroids made of the same material can have different colors. All this and more in this week's Space Bites. Our intensive coverage of Comet 3I Atlas continues. And this week, we've got some observations from the James Webb Space Telescope. Now, Comet 3I Atlas was discovered, and what makes it very different from the other interstellar objects that are coming through the solar system is we are seeing this one inbound. So now we get observation after observation as it is getting closer and closer and starting to evolve and producing the coma, generating its tail. It's all happening in real time, unfolding in front of our eyes, and we're just getting better and better information about it. And of course, one of the greatest observatories ever built is James Webb Space Telescope, and it has done some very detailed observations of 3I Atlas. It took its images on August 6th, at a time when the comet was 3.32 astronomical units away. And it discovered something pretty amazing, which is that the coma, this is this cloud of gas that surrounds the nucleus of the comet, is made largely of carbon dioxide. And this is not normal. The ratio of carbon dioxide to water in the coma is 8:1. We've never seen an Oort cloud comet with this kind of ratio of carbon dioxide to water in the coma. There's other chemicals in the coma, of course, and one of those is carbon monoxide. And yet the ratio to carbon monoxide to carbon dioxide is not normal either. It only has a ratio of 1:4 for carbon dioxide to water. So that's bizarre as well. Normally you would expect to see carbon dioxide and carbon monoxide go hand in hand. So what's going on? Well, we don't know. I mean, this comet came from another star system. And so it started out with different raw materials than the comets that we have here in the solar system. It also traveled through space for millions, maybe even billions of years, exposed to radiation, dust, and who knows what impact that had on the comet. So the mystery continues to unfold. We will learn more as it just keeps getting closer and closer. Lots of time, the perihelion, when it gets its closest point to the sun, is still in October. There's going to be a close flyby of Mars. So the Mars Reconnaissance Orbiter is going to be able to take an image of it. So this is still just the beginning, and we will be able to continue to give you new information every week. If you want more information about the actual observations, check out the story by Andy Thomaswick on Universe Today. And speaking of interstellar objects, we now know of three. We have Oumuamua, we have Borisov, and now we have 3I Atlas. And that gives us a chance to study three different objects. Now, there are some people out there who are saying that these objects are behaving strangely, that they could indicate that they're not comets, but actually are alien probes that are making their way through the solar system. Well, okay, that's a tall order. And the problem, of course, is that whenever you invoke aliens, aliens can do anything. Can the aliens make crop circles? Of course they can. Can the aliens move at faster than light speed? Of course they can. And so if you're going to evoke aliens, well, the aliens can explain every possible thing that can describe the object that you're looking at, and therefore it provides no explanatory power. But there are things that aliens could do that would make an object unusual enough that, in fact, that it is some kind of intelligent piece of technology becomes the most likely possible explanation for what's going on. So there's a new paper that came out. James Davenport is one of the authors on this, and we've done collaborations in the past. One of my favorite YouTubers / actual scientists. He proposes that there are four technosignatures that you should be looking for in an interstellar object that might indicate that, yes, indeed, these are aliens. First up is unnatural movement. And this was something that was brought up by the movement of Oumuamua, that it was accelerating in a strange way from the sun. This has been easily explained by gas venting out of the comet. It's not moving in a dramatically different way than what you would expect if it was powered by a solar sail or it had a fusion thruster or something like that. So things got to move in a way that you just can't predict by any amount of gas venting out of the comet. Second, You need an unnatural spectra. In other words, you need to point your telescopes at the object. You need to examine the light that's coming from the object, and that will tell you what it's made out of. And the things you're looking for that are normal are things like rock, metal, gas, dust, ice, things like that. But if you see other stuff, or a lack of certain kinds of chemicals on its surface, viewports, the reflection of a chrome surface, then that could lead you to believe that maybe this is of technological origin. Next up would be a strange shape. And this is something that baffled people with Oumuamua, that has this 10-to-1 width to length ratio, which has never been seen in a comet before. But it's not like impossible, and people have provided some very reasonable explanations for how you make it an object that is that weird of a shape. And so you need something that is like battlecruiser shaped. You need something that is definitely a solar sail shape. You may see hints of a weird shape, but really you have to be able to get enough of a resolution of an image that it can show you that it is unnatural in origin. But the most important one, the fourth, the smoking gun, the one that tells you that this is of alien origin, is some kind of transmission, some sort of signal coming from this object, whether it's sending in radio waves or laser beam, that you're seeing some kind of signal that you would normally absolutely not expect coming from an object. And so until you meet all or some of that criteria, you have to just say by default, this has got to be something that is natural. But obviously, you want to keep your hopes up. You want to make more observations. Definitely point radio telescopes at interstellar objects as they're passing by to see if you can get more information. And maybe, just maybe, eventually, we will find that von Neumann probe that is passing through the solar system. Now, we've got a great story about this, again, by Andy Thomaswick. What is inside of Mars? Now, for the longest time, this was a mystery. We had no idea. How do you know what's inside a planet? Well, we do on Mars what we did on Earth, which is that you listen to seismic activity with seismometers. Earth, we have tons of seismometers all around the planet, and as an earthquake happens, as any kind of shaking and rumbling goes on, these send waves through the planet. These pass through the different layers, they change their shape, their direction, they bounce, and over time, geologists have been able to work out the interior structure of planet Earth. And so, to ask the same question about Mars, NASA sent the Mars InSight mission to the planet. It has a very sensitive seismometer that it placed gently on the surface of Mars, and then it listened for years to various seismic activity. It detected over 1,000 Mars quakes, and by doing so, scientists were able to map out the interior of Mars. And now we got a new paper that talks about how there actually are chunks, blobs of denser material floating around inside Mars. And geologists think that these are the results of giant impacts that crashed into Mars about 4.5 billion years ago, pretty much around when the solar system formed. And that these objects would have to be in the several kilometers across, 2+ kilometers across. And there are a lot of them that are just floating around, slowly descending, caught up, separated from the regular interior structure of Mars. We knew this, but the early solar system was a very dangerous place with rocks raining down from the sky onto all of the objects in the solar system. Now let's move to another planet, Jupiter. And like the Earth, Jupiter has a very powerful magnetosphere. That magnetosphere interacts with the solar wind and that creates auroras. But Jupiter's magnetosphere is many times more powerful than the Earth's magnetosphere. And so it behaves a little differently than what we have on Earth. When you look at the auroras, this is the result of the solar wind particles being driven down into the Earth's magnetosphere. They interact with the atmosphere and you get the auroras. On Earth, the auroras form this donut around the poles where you have auroral activity away from the poles, but not actually a lot directly over the poles. But on Jupiter, You do have that donut, but then the donut is filled in. And it turns out that this is a result of both the intense magnetosphere around Jupiter that is pulling these particles, driving them towards the poles, but you also have a low plasma density environment. And Jupiter's upper atmosphere is very different from Earth. And so the colors of the auroras are not seen in the sort of blues and purples and reds that we see on Earth. They're seen in ultraviolet. And so it takes very special instruments to be able to see them, such as what they have on the Juno spacecraft. So thanks to Juno, we're learning a ton more about Jupiter's magnetosphere. And also, Juno might be canceled soon, even though it's a perfectly operational spacecraft. All right, we got more about this from Mark Thompson on Universe Today. And speaking of Jupiter, ESA's JUICE mission is on its way to explore the planet and mostly its large icy moons. It's going to reach the Jovian system in 2031, but to get there, it's got to do flybys. And one important flyby happened on August 31st when it made a close flyby of Venus. And that's a spoiler alert for what I'm about to tell you, which is that about 6 weeks before the flyby, the European Space Agency lost contact with the JUICE mission. They did a bunch of troubleshooting and they were able to confirm that it wasn't the ground tracking station, so it had to be a problem with the spacecraft. When the JUICE mission is out of contact with Earth, it goes into a survival mode where it starts to rotate and it sweeps this antenna past the Earth every hour. And then that allows the controllers to be able to make contact with it. Well, it wasn't doing this. They were receiving no contact with the spacecraft. And so now the engineers at ESA had two ways that they could deal with this. One is wait 14 days for the spacecraft to go into an automatic restart. And then it would then begin communicating again, and hopefully they'll be able to restore contact. The problem is they lost contact on July 16th, and this is getting pretty tight, pretty close to when it's supposed to do the flyby on August 31st. And that gives you less time to be able to deal with any issues, especially if there's something wrong with the spacecraft. So plan B is to just send blind messages in the direction of the spacecraft, hoping to send the kinds of signals that could be picked up by JUICE, and it would be able to take those commands and act on them to be able to restore contact. It took them about 20 hours straight of working through the night. And of course, you're dealing with this 22-minute delay between Earth and the current position of the JUICE mission. But good news, they restored contact in time so that they were able to do the flyby. And actually the flyby just happened on August 31st and everything went fine. So the mission to Jupiter continues. And we've got this great kind of blow by blow breakdown of what happened by Matt Williams on Universe Today. Every week we do a vote on our channel. We tell us what you thought was the best space news story of the week. And the winner last week was the Flight 10 of Starship. That's not a big surprise. So thank you everybody who voted last week. We're going to put the vote to this week's Space Bites into the post tab here on our YouTube channel. Of course, the best chance to see it, subscribe to our channel, click on the notifications bell, and then just go through the post tab and just vote on a whole bunch of stuff. And then you should see that vote in the future. One of the most iconic supernovae remnants that we know of is called Cassiopeia A. And this is an object that's located about 11,300 light years away from us. And from what we can tell, we saw the supernova in the sky in 1660, but there are no astronomical records of it happening then, but it has since been discovered and people are finding all kinds of information about it as time goes on. We are watching this very early on, like it happened after the Crab Nebula. So we're watching this wreckage expand outward in real time. And astronomers took the Chandra X-ray Observatory, another mission that is up for the axe, to examine the center of Cassiopeia A. Because it's such a fresh supernova remnant, they're able to see a lot of detail down at the heart of this object. What they found is there are regions of silicon that crashed into regions of neon. Astronomers think that before it exploded, the precursor object was a star with about 15 to 20 times the mass of the sun, maybe 30 times the mass of the sun. It was a red supergiant. Think Betelgeuse. And so when it ran out of fuel in its core, got all the way up to iron, all of its outer layers collapsed inward and piled up, and then you got this core collapse supernova. You have these shells of different elements inside the center of the star. Essentially, these are the different fuels that it went through as it was going through the fusion process until it reached iron at the core. And now it appears that there's more evidence that these various shells actually mixed together quite a bit. When astronomers looked at the center with the Chandra X-ray Observatory, they found where you could see how silicon was colliding with neon. And so instead of it being this very rigid shells exploding out from the center of the supernova, in fact, you got silicon that was piercing through in blobbers through the neon shells, and everything was mixing quite a bit. And this is really interesting because we know that there are supernova remnants, neutron stars that are moving on enormous speeds through the galaxy. And the question is like, how do they get such a big kick? Well, if you get this mixing, instead of it just being this really smooth distribution, you can get this asymmetrical kick where some chunk blasts through some other part of the interior of the star and it acts like a thruster, kicking the star in another direction. And we're seeing how these different layers can actually interact with each other. We've got a great story about this from Evan Goff. All right, time for some images. And first up, check out this incredible image from the Daniel K. Inouye Solar Telescope. This is a ground-based solar telescope, the biggest on Earth, the most powerful, and it is showing you an X1.3 class flare that happened on the surface of the sun. It's like hard to get across how good this picture is, that you're seeing a region that is several times the size of the Earth across, and yet the Daniel K. Inouye telescope is able to reveal features as small as 21 kilometers across. And so one of the big arguments that astronomers have had for a long time is like, what is the thickness of the filaments that are in these flares, these coronal mass ejections, this stuff, these blobbers being thrown out of the sun? It shows that they're actually a lot thinner and a lot stringier than astronomers had originally thought. And so this is an incredible picture in such detail, and like the scale is mind-bending. And this telescope is like nothing else we've got on Earth. Because it is directly imaging the sun, they have this active cooling system that keeps the whole telescope cool. They have 11 kilometers of active coolant that is running through the telescope nonstop to try and dissipate the heat, because it is looking at the sun, which is a thing you are not supposed to do, and yet this telescope does it. But we've got a real interesting breakdown of all of the bits and pieces in this picture by Mark Thompson. And now I'm going to show you some butterflies, but like space butterflies, like stars being space butterflies. First up, this is the newly forming planetary system IRAS 040302, which is about 525 light years away. And we've seen many newly forming planetary systems, and the best pictures come from ALMA. And a lot of those are seen face on at a bit of an angle, and you can see the rings of material in this newly forming planetary system. You can even see little knots where planets are starting to form. But this image, which was taken by James Webb, you're seeing a protoplanetary system seen edge on. And so instead of seeing the rings of gas and dust, you're seeing the thickness of the actual dust disk itself. You're seeing the outflows of gas that are coming from the star along the poles of this newly forming star. And this is giving astronomers a chance to understand, like, what is the thickness of these disks? But it's just an incredible picture. And then another picture called the Butterfly Nebula, also known as NGC 6302. And this is another image taken by James Webb. And this is the other end of the spectrum. This is not a newly forming star. This is a dying star. It's a white dwarf. But it's really interesting to see this kind of same sort of position. You're seeing it edge on. You're seeing the outflows of gas and dust as the star went through its death throes. And thanks to James Webb, astronomers are able to see a lot of carbon-based molecules in these outflows of material. If you could get really close or have it here on Earth, it would look sort of like smoke coming off of a campfire. And this is dust. You know, we talk about how dust is getting in the way of everyone's observations. Well, this is one of the sources of cosmic dust in the universe. Now, you are watching this week's Space Bites, and we covered a lot of stories here, but this is just a fraction of all of the stories that we're covering over on Universe Today. We have a team of skilled science journalists who are writing about really cool ideas about space and astronomy. For example, that metals are critical to life and we should be screening exoplanets for them. Story by Andy Thomaswick. Astronomers used a double gravitational lens to study a quasar. That's a story by Matt Williams. And that scientists have proposed some other liquids that could be solvents for life as we don't know it. And that's a story by Andy Thomaswick. I gather all of these stories into my weekly email newsletter. I send it out every Friday. It goes out to 72,000 of my closest friends. It's completely free. I rate every single word. Definitely check it out. If you want to subscribe, go to universetoday.com/newsletter. But if you are enjoying the video version of this news and you want one more story, good news, we have a version of this exact video with one more story that we release that over on Patreon, but it's completely free. There's no ads. You don't have to be a member. You can just go watch it right now. And the story is about how different asteroids made of essentially the same thing can have different colors. I'll put a link in the show notes so you can check out this version, and then you should just check out that version by default every week. I'm going to talk about the media that I am consuming, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Barely Griffin, Brian Body, Caradwin, Chuck Hawkins, Commander Balock, Cy Nelson, David Gilligan, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Monzo, Nick Borges, Nick Solari, Paul Robach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I just got a few administrative things to clean up today. The first thing is what I am playing, which is that we've got the new season of Path of Exile 2, and I skipped the previous season because there wasn't new content, just a new class, but now they've got Act 4, so I am currently replaying Path of Exile, and I'm going to get through Act 4. I probably won't continue on to the end game. I just want to see how Act 4 works out, but Path of Exile 2 is shaping up to be just a great AARPG, so definitely check it out, and I think you can access it free now. What I'm watching is a bunch of the same stuff. We've been watching Foundation, watching Chief of War, but the new show that's come on is Alien Earth, which we're watching on Disney, and it is so good. Like I'm putting it up in my S tier. For All Mankind, The Expanse, Love, Death, and Robots, Andor, and Alien Earth. Those are like now my top 5 favorite space-related TV shows. It's so good. And if you don't know, the showrunner is Noah Hawley. He is the same showrunner as Fargo, and he also did Legion. And Legion was weird and good, but like whenever you have a TV show and someone wants to go weird, then you got to be really careful. You can go too weird, and it's just like it doesn't make any sense. And with Legion, they were always sort of walking that line between this is really cool or this is too weird, I'm out. But with Alien Earth, so far, the first 5 episodes, it has been all just great. And I'm really enjoying it. So if you haven't already checked it out, definitely watch Alien Earth. And then just one last piece of information, which is that our live show is returning. So by the time you're watching this, this is the final weekend. We'll be back on Monday, September 8th. At 5 p.m. Pacific time for the live show where I sit and I just answer your questions unscripted for 2 hours. So there is already an event here on the channel. So check that out and we'll see you on Monday. And we'll see you next week.